We're going to start by looking at logarithms of base 10. So 10 to the power 0 is equal to 1, 10 to the power 1 is equal to 10, 10 to the power 2 is equal to 100, 10 to the power 3 is equal to 1,000, etc. And we're going to use these facts to work out the value of x for 10 to the power x equals 5. So we know that the value 5, this 5 here, is somewhere between 1 and 10. And what that means then is this exponent here must be somewhere between 0 and 1. And we can guess at this. We can say 10 to the power 0.5, and we can guess and say, so 10 to the power 0.5. If we take the square root of 10, we end up with 3.16. And then we can guess a bit bigger. We can say 0.7, and 10 to the power 0.7 is going to be 5.0118, etc. And we can then guess a little bit lower, 10 to the power point, maybe 65. We end up with 4.668. Okay, and we can keep guessing. We can guess. We know we're somewhere between a little bit less than 0.7 and bigger than 0.65. So we can just keep on guessing, and we can keep guessing to get any desired accuracy. Now, we can do this. This is essentially logs when we're solving for the exponent, but we can actually solve for the exponent in the log form. So we can use our definition of our log, which is what we have over here. We can use this definition and convert this into its log form. So I'm going to end up with log. Okay, my base is 10. So I'm going to write 10 in my base. I know that 5 is my argument. So I'm going to write 5 as my argument. And then that's going to be equal to x. And I can actually type this into my calculator and solve for x. So I end up with x is equal to log 5 is 0.6989. So I'm just going to round that to 699. So our calculator has base 10 built in it. And we can use our calculator to solve any base 10 problems. Now, that only works for base 10, but for other bases, we're going to have some other workarounds. So this is what we're going to do here. We're going to solve for the exponent. We're going to convert it to log first and then solve for the exponent. So in this case here, we're going to convert it into a log expression. So we have our log, we have our base, we have our argument, and we have the exponent. Okay, so when we write this in terms of the log, we need the log of the base and the log of the exponent must match. The log always equals the exponent, and the argument goes inside the log. And when we type this into our calculator, we're going to end up with log base 10 of 20. Log base 10 of 20 works out to be 1.301. So we end up with A is equal to 1.301, and that's what we calculate from our calculator. So again, same thing here. We're going to convert this to log. We need our base to be the base of the exponent here, and we have our argument. And we know that when we put this in, the base of the log must match. We know the argument is inside the log, and the answer to this is going to be the exponent. So plugging this into my calculator, I get log of 4,000 is equal to 3.602. So B works out to be 3.602. Okay, and I'm just going to tack on a few more decimals, so it's 0.5999. So I'm just going to do this in a slightly different color here. So 2.05999. Okay, and the reason why I'm going to do this is be evident in a second. So when I calculate x for these, for example, 3, I'm going to plug into my calculator and log base 10 of 4. My calculator gives me a value of 0.602. And if I look at the decimal values at that continue on, it's 0.5999. Now, if we take a look at the previous example, that looks like there's some sort of relationship here. This value here and the decimal value here seem to be related. And if we take a closer look at log of 4, we can see that we have log 4 and log of 4,000. And it's pretty easy to see that probably that decimal 0.602 in both cases might have something to do with the 4 in both of those logs. And in fact, some of you may even jump to another conclusion that 4,000 is really 4 times 1,000, and 1,000 log base 10 is going to give us the 3 here. And if you are seeing that, you're seeing the right thing. There's definitely some sort of connection here. It's not a coincidence. There's a connection. We'll get into that connection maybe a little bit later on. So here, then, we're going to work out the last ones here. So we have log, again, base 10. Our exponent is going to be x here, and our exponent is going to be the x, which I'm going to do in a different color, and our argument is here. So when I write my log in, I want to have my base, my base 10. So I need to write that into my log base 10. The argument is the answer to the log, and the log always equals the exponent. Okay, and then typing this into my calculator, I get log of 83 is equal to 1.919. So x is equal to 1.919. That sounds about right because x to the power 2 is going to give me 100. So we're getting pretty close to 83 is close to 100.